Let's do a little reteach of lesson 1 and 2. So first off, looking at lesson 1 and absolute value. Answer the following questions involving absolute value. So I like to write underneath, and if we're needing to reteach, it's probably a good idea to do these extra steps so you don't make the mistakes. So absolute value of negative 14 is 14. It's always that positive value. Plus the absolute value of 10 is 10. What's 14 plus 10? 24. Number 2, looking at each one individually, absolute value of 15 is 15. It's that positive value. Plus the absolute value of negative 21 is 21. And now I'm just adding 15 plus 21 is 36. Number 3, like we talked about during the lesson, we have to compute within those grouping symbols of absolute value first. So I'm going to calculate 40 minus 15 is 25. Then we're calculating what is the absolute value of 25. It's 25. Next one, number 4, we're calculating within those absolute value signs first. 57 minus 7 to get 50. Then calculating the absolute value of 50 is 50. Let's talk about opposites. So the next part of lesson 1. Remembering that this negative on the outside is meaning the opposite of this number on the inside, negative 9. What is the opposite of negative 9? The opposite of negative 9 is positive 9. That double negative means a positive. Same thing here. We have this negative on the outside. That means the opposite of our number on the inside, negative 15. The opposite of negative 15 is positive 15. Double negative means a positive. And one more, just to really make sure we understand it. This negative on the outside means opposite of our number on the inside of the parentheses, negative 3. The opposite of negative 3 is positive 3, so that double negative is a positive. And then writing integers to represent situations from lesson 1. Really, we're just looking for these keywords, and I'm going to highlight them this time. So profit is our keyword. He made a profit. So if you don't know what profit means, if he made money, that is a positive thing. So positive 75. Stephanie is $20 in debt. Being in debt means to owe money, so that is a negative value. A submarine is 55 feet below, whether you see the whole thing below sea level or just below, either way, below means negative. And plus, a submarine is below sea level. It's underground. It's a negative value. The kite is at an altitude of 30 feet. If you don't remember altitude, just think about a kite. A kite is up in the sky. That is a positive value. Manny withdrew $50 from his bank account. The key word is withdrew. A lot of times people forget this word. If you don't remember withdrew, look at the word. It says from his bank. He's taking it out of his bank. That is a negative value. His bank account is going down. And then the last part here, this tends to be the tricky part, classifying numbers. So we try to break down the table a little bit more for you here so you can look at what is important. What I like to do is kind of draw a little divider right here, okay? Because it's either rational or irrational. So if it's rational, you're not checking off here. If you've checked off for irrational, you're not checking off any of these over here, because all of these are different categories of rational numbers. And as we talked about this entire unit, we are doing real numbers. So what I'm gonna do right away is I'm just gonna put a check under real numbers for every single one that we have here. So now let's go through. First thing that I always need to check is, does it actually divide out to a whole number? So 8 divided by 2 gives me 4. So the number 4. 4 is not a fraction, it's not a decimal, it's not negative, it's not 0. So yes, it is a natural number. As soon as I've checked this off, it is also whole, it is also an integer, it is also rational. You can't have any gaps in between, because if it's this, it's all of those. And if it's this on the right, it doesn't mean it's the others. But if it's this on the left, it's going to follow all those up into that green line. All right, 9.7 repeating. I see decimals, so it can't be natural. I see decimals, so it can't be a whole number. I see decimals, so it can't be an integer. Now we're deciding, is it rational or irrational? So it's no never-ending decimal. So decimals that don't repeat do not apply. Okay? So since this is a repeating decimal, this is rational. All right, -5. So we have a negative. We don't have fractions, we don't have decimals, so we have a negative. So it's not natural. We have a negative, so it's not whole. Integers don't say anything about negative, so it's fine. There's no fractions, there's no decimals, so it is an integer. If it's an integer, it's also a rational number. 0, well, specifically right here, I see no 0, so it can't be a rational number. It doesn't have a fraction, doesn't have a decimal, it's not negative, so it is a whole number, which means it's also an integer and also rational. 5, pi. As soon as I see pi, pi is our most common irrational number. It goes on and on and on forever without a pattern. So as soon as I see that, it's irrational. It's none of these rational number spots. 1/4. It is a fraction that does not simplify to a whole number. So I see no fractions, no fractions, no fractions. Okay, rational numbers have fractions, so it applies there. Okay, number 3, there's no fractions, there's no decimals, there's no negatives, there's no zeros, so therefore it is a natural number. If it's natural, it's whole, it's an integer, it's rational. Every single natural number is also a whole number. The only one that isn't both is 0. And then our square roots. First, we got to see if we can simplify. Square root of 9 simplifies to 3. Well, we're back to the whole number 3, which we already had, which was natural and whole and an integer and rational. And then last one, square root of 10. If I tried to simplify that, it doesn't work. Think of your perfect squares. Our perfect squares are 1, 4, 9, 16. 10 isn't any of those. So it's not a perfect square, so it's going to be a decimal that goes on forever, which is irrational.